Namaskar, good evening, and Guru Scott to all of you. Welcome to the online seminar on early years coding. Today, we are going to talk about computational thinking. We are going to go deep into the topic, understand what it is about, and then get a hands-on on the topic. But before we begin, let's have a quick introduction about Haba. Haba is a German brand which was started in 1938. We are a group of educational brands which has a common goal. The common goal is shaping learning worlds together. When we talk about learning worlds, we talk about the different brands of the Haba group, which you see right now on your screens. We provide learning aids, we provide digital solutions, we provide workshops. In all, we provide a one-stop solution for schools and kindergartens. We are active in more than 50 international countries worldwide with more than 2,200 people at different locations. And we work with in-house experts along with partners from industry and domain experts, both in research and product development. This is to ensure that we provide you with the best solutions for children which are pedagogically developed. Before we start the session, I would like to take the opportunity to introduce the panel today and talk a little more about what we are going to do in the session. Well, on the panel today, we have somebody who really inspires me. To start with, we have Professor Dr. Ute Schmid. She's a lady who wears several hats, has many responsibilities, and it's a pleasure for me to welcome her today. She's the head of Cognitive Systems Group, University of Bamberg. Also, she is one of the directors of the Bavarian Institute on Digital Transformation. In addition, she is the head of the Fraunhofer Institute for Integrated Circuits Project Group on Explainable Artificial Intelligence, and she heads the research group of elementary and primary informatics. Thank you so much, Professor Dr. Schmid. Thank you for taking time out for this. Thank you for being here with us. Also on the panel, we have Mr. Anders Fuchs. Mr. Fuchs is Manager Digital Education for Haba. He has been with the company for more than a decade and has been substantial in his contributions on development of products for digital education. I've known Mr. Fuchs for a long time now. We've worked together on several projects, and I'm very happy to welcome him and, of course, Professor Dr. Schmid today for this very important seminar. My name is Samriddhi Sharma. I am the Managing Director and the CEO of Haba in India. And it's a pleasure for me today to welcome all of you, our dear audiences, our dear viewers from around the world. I see we have participants from so many countries. It's such a pleasure to see that. So welcome one and all, welcome partners from around the world. And of course, thank you ScooNews team for having us on board and organizing this for us. Wonderful job done. A quick input on the session today before I hand over the spotlight to our experts. Well, the session today is on computational thinking. We will get an insight on what computational thinking is, why is it important, but we'll also do a hands-on on some of the products for coding in early years. And this would be done directly live at the University of Bamberg, where our experts are currently sitting and waiting for us to showcase the solution and the products that we have. So before further ado, I would like to hand over the spotlight to Professor Dr. Schmid and to Mr. Anders Fuchs. It's all yours. Please take it forward from here.
Thank you very much, Samriddhi. Greetings from Bamberg.
Hello, greetings from Bamberg, from me also.
Thank you very much for the warm introduction, Samriddhi. So actually, we don't want to spend that much time in introducing ourselves. We discussed before. So we will start immediately with our work and presentation. So actually, what we did in Haba with the digital education part is we try to do all the time the best for our kids. Me and myself, I have 3 kids. One is my daughter. She's 10 years old. I had the first iPad I bought it, and so, well, I got a lot of inspiration from her, how to use the digital stuff there. And actually what we do, we think is, how can we support kids, parents, and especially schools and kindergartens in learning in the futures. So actually, sorry. So this is at the moment the situation we have, like, all over the world. As you see, if you say we want to do any modern lessons or what else, we have the same classrooms and we have like a screen put in or whatever. So this is actually something that is not a very good thing. This is old-fashioned, and this is nothing we want to support. And actually, I'm sure that we have to change it, or we are sure that we have to change it. And seeing the kids in the other photo, so this is also nothing that we really want to do, so that everything is changed, or they're just using screens and programming. Just using screen is nothing that helps us in the future. Actually, we have to give them the skills for the futures. So what did we do, or what is our thinking in this part? So we have several blocks there. The first block is learning with digital media. So even if you say this is nothing we should do, just only learn with digital media, it's very important that the kids know how to cope with these media. Nevertheless, they really have to know the background. So this is the learning about digital media stuff. Well, they need the basics. We have to give the information to the kids, and they have to understand, because actually they need to come from they have to be creators, and they have to stop to being just only consumers. So this is very important, but this can only be done if they really know about what they are talking about. So, and the third very important thing there is the learning environment. It's very important. The pics you've seen, this is something like we all have been in schools, and now our kids are in the same situation. So nothing has changed in the environment, but we have to change it. And the basic of all this is our consulting and training. So there's a lot of variety in the schools. So there are a lot of different things that need to be tackled, need to be covered. So they need to come some kind of consulting, and the stuff, the teachers needs to be trained. That's why we have this button. And all this house we built there is the blended learning house. But today I just want to focus on give you the overview, and I want to focus, or we want to focus on showing only one thing today. This is the learning about digital media. So learning about digital media, Ms. Professor Dr. Schmid, we are talking about computational thinking, and I want to give the word to you.
Yes, I hope that you already know this term computational thinking. Nevertheless, I try to flesh it out a little bit for you. In general, computational thinking means the ability to recognize problems, to apply abstraction skills, and to identify the individual steps needed to solve a problem. Solutions, computational thinking solutions, are intended that they can be implemented both by people, the children themselves, for example, performing algorithms, executing them, and by programming, for example, in a visual programming language, implemented on a computer. Both is possible, and we think that it's really important when you start early training in computational thinking that children start with a haptic environment to experience how computational thinking works as a basis for computer programming in a next step. So what are the typical parts you look at when you look at computational thinking skills? One important skill is to separate complicated tasks into disparate solving problems. In computer science, we know about a specific class of problems called divide and conquer problems, which are a class which you can solve efficiently by splitting them up in independently solvable subtasks. And it's a big, big achievement for children as well as adults to recognize how you can split a task up in this way. Another part is pattern recognition. Here is the idea that you have to recognize regularities in a stream of information. We all do this when we learn our mother tongue. For example, we extract the grammar rules behind it, how to build a correct sentence, just from a stream of experience, which is amazing, and which is, to tell you the truth, one of the reasons why I became a researcher in artificial intelligence, because I really want to try to mimic that. Yeah, people are amazing in this, children are amazing in this. You know, maybe that pattern recognition lies also behind most of machine learning, which is quite hype nowadays. The core, I would say, of computational thinking is algorithms. Here is the thing that you have a defined first initial state or input and a specific goal or output. And you have to think about a systematic way to transform arbitrary inputs into outputs. For example, how to calculate the factorial of an arbitrary natural number would be a typical form of an algorithm, or how to subtract two numbers, but also in other domains like stapling blocks and so on. So this is the core, and there are many, many really haptic basic tasks where you can train children already at very young age, let's say starting at 4 or 5 years, to start this recognizing how can I solve a problem in a systematic way. And the final part of computational thinking is abstraction. From specific examples, grasp the general principle, learn the abstract problem-solving scheme, which you can apply in new contexts. So I talked a lot, I'm sorry, but I am really enthusiastic about this domain. And maybe we can go to the next slide.
I think it's necessary to talk a lot on this topic.
Yes.
So this computational thinking, we've seen as a huge thing, as a huge problem. And what we've seen on the market or in the schools is everybody is sitting the kids immediately to the screen and start programming. And then they say, okay, they must be genius. But in our opinion, it doesn't work. And even in Professor Dr. Schmid's, does not work in this way. So that's why we said, okay, we need to do some change. We need to do some more. So we decided to do a learning concept together, and we designed the digital starters. Here they are. These are 5 games. They have no screen, no battery. They have just only analog material. We will give you an insight in 2 of these at the moment. But, well, I want to type out, for example, the pixel game. We won't introduce later on. But as you see here, I've got a pixel here, which is analog pixel, and I have a smaller one. So you can, with this, you can understand what a pixel is and how does it work in our games there. Okay. These are the things, and we really needed a development partner. That's why we working together with Professor Dr. Schmid and University of Bamberg. So
yeah, so I will tell you a little bit of the background of my research group called FELI, which sounds a little bit like a female given name. FELI is short for our research group of elementary and primary computer science, and actually I do this since 2008. Anders Fuchs already told about his daughter. I can tell you about my daughter. So I'm a professor of computer science, but also a mother. And in 2008, my daughter was in kindergarten. She was 4 years old. And the head of the kindergarten asked me, well, couldn't you visit you at university and see what you are doing there? And so I was kind of forced to think about what do I do with 4 to 5 year old children that they understand what computer science is about. I already had experience because I'm women's representative of my faculty with doing computer courses for older girls, age 10 and older, but this was really challenging to address this young group of students. And so we came up with this type of place Andres Fuchs showed you on the slide before. And what did we do now since more than 10 years? We promote that you always have to look at both learning with computer media and learning about them. Otherwise, as Anders already said, but you can't repeat it too often, you have no chance to become a digital independent, become a creator and not just a user who does not understand what are behind the screen, so what is behind the screen, so to say. One of the leading questions driving natural sciences is why. Yeah, you know Newton, why did the apple fall to the ground? The leading question for computer science is how does it work and how can I make it better? And better meaning you can make your programs more efficient, more secure, more usable, whatever. And this is what we want to teach. We have a practical experience in workshops since 2008, and at the same time, we do research on it. We publish papers on this. We observe systematically what children are doing, what type of material is cognitively adequate and can support them. And we also keep in mind that we produce material which teachers in kindergarten and primary school can really use, because typically teachers in primary school and kindergarten have no real background in computer science. They have a background in education. So you need to make sure that the materials are robust enough that laypersons can apply them without doing something wrong and teaching concepts wrong. And I think I'm really proud that we could do this with these games, which we will show you later.
Okay. So now we are switching to the presentation of the games. So I will, I will switch the camera here. So. Sorry, wrong button. Now it's working better, right? So, okay, we decided to have the game Coding Architect here. Sieht man's? Yeah. So, what is a Coding Architect about? I'm able to program, and I love to program, even if it's not the same level as Professor Dr. Schmid does.
Maybe if I can quickly interject, because you're speaking from a different mic, we can't see your screen with the game. Maybe you can use the same audio from the device where the products are.
You can't hear the audio?
We can hear you, but the screen in focus is not the game. So, because we can't see it right now.
Okay.
This is, you have speaker view and not gallery view, maybe. Yeah. You should select speaker view. You should select gallery.
I think the moderator should make this as...
Yes, go ahead, go ahead.
Okay.
Yeah. Okay.
You've done the change? Is it
yes,
better?
Go ahead. Yeah.
Oh, perfect. So, starting with the introduction of Coding Architect, somebody just interrupt if it's not that good at the moment. Okay, Coding Architect, what is this all about? So I'm able to program even if it's not the level of Ute. Nevertheless, I really love it and I like it. If you go to the kids and say you can create virtual worlds, it's great. and this is the code for they see and look at the world. And because we want them to be the creator, if you show them the code, they can't combine it. Even if it's Scratch, it's hard for them to see the difference. So we had the idea to give the kids one of these cards you can see here, and this is the code. It's actually object-based programming, analog object programming. So if you see here the object, you have to put this wooden block on the position 2 and 4. So if I do it, I put it on 2 and 4. You see, and this is the code, and actually there the world is growing. So I just prepared it already. I use the steps on 3, 4, the next on 4, 4, and so on. So actually, this is what we did because of the code we had. And if you just switch the card, you can see this is the control there, right? So this is the real world we created, even if you see it from the top. And this is the world we wanted to do.
You come down, can't see anything im Chat.
Okay.
Die müssen das Bild sozusagen für alle sichtbar machen.
We just receive chat messages that people don't see, but now we see it's visible. Okay, thanks a lot.
It's visible. Please go on.
Visible. Okay,
Yes,
so
yes.
Fine with this. So as you, what you see here is a very similar card, a very easy card, and we have 3 steps on, to make it some harder for the kids. And this is actually like 3 levels right there. And I've also prepared one harder level so that you can see this something more is possible. Even this is crashed right now. So actually, but the same situation, you have to put the blocks on 2, 2 right here, and so on. Okay, this is the first game actually we have, but we decided to give the kids more creativity. So I wanted to show you for the first thing I already built in the first step. So we give them a tablet, and they can also do their own individual worlds. This is just only one example. They also could base a block here or whatever. And then they have to create their code on their own because all these cards are included in the game. So they just put it there and put the position right afterwards. So this is the individual code the kids have. Usually what they do in the kindergarten or school is that they build it, then they do the code, and afterwards they destroy it, give it to the second group and say, please rebuild it with this. Okay. So this was the game Coding Architect, and we will go on with Search and Sort.
okay.
Yeah. So in the game Search and Sort, we have several stages. Here is the cover again. Sorry. So first thing is just to sort different varieties. There, for example, you see how dark or how clear the color is, and this is different size of the animals. So actually, the kids know how to sort it. It's very easy for them. Bringing this to a small little bag, and it's much easier, much harder for them, because actually they have to search and have to find which one is the tallest one, or they say this might be the tallest one. If they see this, then it's okay, and they have to build it in a several stage. So actually, this is the world where the kids are in kindergarten and primary school at home, because they know these things like wooden blocks and so on. But if you want to sort something else that looks quite similar, it might be harder. So here we have something that looks exactly in the same way, but you also need to sort it.
Okay.
Maybe.
So, Yeah, so what Anders already showed you with the animals and with the colors is that you can simulate the principle of specific sorting algorithms there. One of the basic ones is, for example, selection sort. This is what computer science students learn in their first semester. And this is a systematic way to sort arbitrary sets of objects by some characteristic, for example, size or color. Now what we have here, you don't see any differences. So we humans are very good at seeing up to, let's say, 7 or 8 objects at once and grasp the relations. But when we want to illustrate to children and to adults how a computer is working and how the sorting algorithm works on a list or an array represented in a computer, the core concept is that you only always can look at 2 things simultaneously and compare these. In this case, these different cylinders can be discriminated by their weight, which you don't see. When I held it in the hand, I can already discriminate, but we have here a scale. And we can say, okay, we have these 2. We are looking for the most heaviest of these cylinders. Okay, obviously this one on the left is heavier. So we do this away, take the next one. Maybe by bad chance, I already got the heaviest. I might suspect this. Yeah, okay, but you hopefully lucky me. So now we keep this one and remove that. Okay, so now we found the heaviest. Okay, we start with the heaviest. Next step. Find the heaviest from the rest of the objects. I don't want to bore you. I'm sure you got the principle and you understand that now you do the same with one object less. And again, find the heaviest of this rest, which you put here. And so you sort the complete set of objects. The interesting thing about our materials here is, I just hesitate because we have a message about that the screen might not be visible. Okay, I hope you see everything. The interesting thing is this: when you want to teach children and adults complex cognitive concepts like this principle of selection sort, it is a good idea to vary the things which are not relevant, that the children or adults are able to abstract the general principle. And what we did here with these scales is the same algorithm which Anders Fuchs used when he sorted the animals by size or the color plates. Yeah, it's the exactly same principle. And I think this is an important message what children can learn just by experience here, that algorithmic principle is a, let's say, general weapon. Yeah, you can solve many problems with the same algorithm. We can switch to searching. And I don't know, Anders, do you like to present search?
Sure.
Okay, cool.
So actually we are in the at the kids' home. So we have explained that it's very important to sort, because the search is much easier. That's why we have this kind of decision tree. And so you get a package of cards to the kids, and they just pick out one, maybe the 9 here, and then actually the presenter does not see, and he has to ask questions. So he's asking, is it the 8, or is it bigger or smaller than the 8? Because it's the 9, it's bigger, so we open that one, and we say, okay, next question is it to 12, or is it bigger, or is it more or less? So because of the 9, it's less. So then the next question is it 10 or is it less? So it's less, so we know that the partner has the 9. So what we demonstrated there actually is that we didn't touch half of the list because we cut it as into 2 parts, and we just needed to put to look or to search in one side. So that's the search and sort stuff to show. So we're switching to the other screen again.
There I a little bit monitored what you wrote in the chat. One person asked, where can I get these games? I'm sure that Anders might answer that. Another person asked, now we get this again, from where can we get all these? But in between there was the question, is this not about computer coding? And if you allow me, do we have the time that I remark on that? It is about computer coding. Computational thinking is to the core of computer coding. And typically, when you are a student of computer science, you first think about these abstract algorithmic principles. And only if you have understood the problem, you sit down and write it, you code it. But coding without thinking beforehand, it's not what a computer scientist should do. This is trial and error, no systematic principles. And I think what the children need to learn is this skill to analyze a problem and to abstract the general solution principle. And they can do this with these games in a very haptic, affordance offering environment.
I think they're in the confidential zone with these games, even the teachers, because they know how to cope with these kind of games. And it's not necessary to start with a screen, start with programming, start with a logical thing before. So back to the presentation. Sorry. So this is the learning concept digital starter we were talking about. So this was the concept we wanted to introduce you. We had a deep dive into 2 games. These are more than, but actually I think this is not necessary now at the moment. Where you can buy them, we will tell you later on. But we want to give you a small insight, what is coming next. So what we are thinking at the moment, what we're doing at the moment is digital starter meets artificial intelligence. And actually, it's our goal to explain a very complex topic with wooden blocks. Would you say some more words?
Yeah.
Not in detail for sure.
Yes. So I think it's the same in India as in Germany and the rest of the world, that everybody talks about AI and everybody thinks AI will change how we live, how we work, how we manage healthcare and so on. And at least in Europe, but I'm sure this is the same in India, people are thinking about how could we explain already our children what this is about? Because AI is not about that there is a superhuman intelligence, Arnold Schwarzenegger, Terminator, governing the world, own consciousness, and so on. Artificial intelligence is about algorithms, intelligent algorithms, which you implement. And one class of these algorithms is machine learning algorithms. And this is what people currently mostly think about when they hear about AI. They think about machine learning. And in our games, we explain, with wooden blocks, how basic machine learning algorithms are working. But we also have games which explore other areas of AI, like heuristic search, planning, and other domains, reasoning, deductive reasoning, and so on, so that children and adults understand that AI is a big toolbox of different methods and domains, machine learning, but also automated reasoning, action planning, and so on. I'm really excited about this, and I remember how happy I was when Haba showed me what came of beautiful games out of basic ideas. And I'm really excited to see our ideas about AI to be produced like this.
To be true for me, as not a really AI expert, I'm reading of this, but I could never understand it. I got the game machine learning. Professor Dr. Schmid introduced us. I got the point and I understood it really, actually just in a small way, but it's very interesting and funny. Okay, so keep on coding. This is our stuff in the back. Samridi?
I mean, in a way, I'm awestruck because this is not the first time I'm seeing the products, but you know, the way we went over it, the way both of you explained it, I became a student again and I was listening like this to everything that you're saying. So thank you so much for the wonderful explanation and the insights you gave, especially Professor Dr. Schmid. I was very, I totally concur with you when you say that, you know, computational thinking lays the foundation of coding, of logical thinking, and that's what we have to start from as early as 4 years, as early as 5 years, so that, you know, the basics of understanding and logic development happens. And I also personally feel that, you know, this is in a way leading to effective decision making at the end of the day, because, you know, when a child as early as 4 years in life is able to identify problems, segregate them, find effective solutions, and then do a logical deduction to decision making, that is absolutely the way forward. So thank you very much. Thank you very much to both of you for the wonderful discussion and the hands-on session. Well, we have a few more minutes left, and therefore we'll talk about some of the questions that we've received that we have. And I would quickly go on to the questions that we've received. So we talked about computational thinking and we talked about why is it important, but the question also remains is, why is an early start important? Because, you know, as early as 4 is something which comes maybe as a surprise. How can coding start as early as 4 years? So the question is, how does starting early with computational thinking make the younger generation future ready?
Yeah, so I think there are several reasons why this is a good idea. Let me start with one which we did not talk at all up to now.
Right.
This is gender equality. Yeah. So I know that in India, many female computer scientists are working and researching much more than in Germany. But at least in Germany, one of the things is when you start early on, the children don't have this gender stereotypes, yeah? And so it really helps to bring girls in computer science or other STEM subjects. I think this is one point for starting early. The other point is that I think not every generation, but let's say every 10 generations, different sets of skills are more important for a successful career, life, and so on. And I think we are in the age of complex problem solving. Yeah,
Absolutely.
Information is at hand. Most of us have access to the internet. Okay, there is fake and wrong things, but there is also lots of wisdom and knowledge to get. So the core thing is no longer to know about facts and to have simple routines, but what we discussed, computational thinking, this is to the core of every career success, and not only in academia, yeah,
Absolutely.
but in all jobs.
Absolutely, I completely agree with you. I think this sort of helps develop the thought process, the thinking abilities in young children at a very early age, so that they approach a certain problem, whether simple or complex, in a logical way. The next question that I have received is, we've talked about the importance of learning environments. Haba anyway focuses a lot on learning environments and making sure that the environment is holistic enough in terms of space, in terms of learning aids, in terms of the entire environment per se. But apart from providing the right educational tools and aids, how can young children still exercise computational thinking? They can still practice computational thinking in their daily lives. And given the current COVID situation, children are at home. How can parents, how can teachers, help them with this?
I think, so I would not say no TV, no tablet. This is not the direction I would take, but nevertheless, I would say, look for a more creative, inspiring, quiet environment. Yeah. Not all the time. I personally think that there is no really right or wrong, but I personally believe that it's really important that children not all the time are confronted with digital media, be it TV or smartphone, but they need to explore things in a more quiet surrounding. Another thing is there should be no fear to do something wrong. It should be an encouraging environment, not a sanctioning. I don't know whether that's the right word, environment. And parents and teachers should encourage the children always when they make errors, for example. Oh, think about it again. Do you really think this is right? Look, maybe you find another way to do it. At least in classical German education, it was different, like wrong, red pen, 0 points, yeah, bad mark. This is not how you create an inspiring environment. This is about selecting people and not about encouraging them to grow intellectually, right? And this is, I think, to the core. And I think these creative games, the games we saw, but in general, problem-solving puzzles, yeah? You can do them also like building a route for a train, where you think, where would the train go when you have different possibilities of intercrossings and so on. All good ideas. Use wooden trains, use building bricks, be creative. That's it.
Perfect. Thank you so much for your insights. I'm sure the audiences, we have a very diversified audience that's seeing this. They're educators, they're parents, there are several stakeholders in a child's life, and I'm sure they're benefiting from the insights that you've shared. Before we close the session, Professor Dr. Schmid, I have also one question which focuses on a common group, a target group, focus group for us, children. And I want to ask this question on their behalf to you. So the question is that if I were to ask you, what is that one advice for the young generation? What is that one advice from your side to them?
Yes, I would say, please understand that the human species is the most powerful on earth with respect to learning. Yeah, appreciate that humans can learn from very young to very old, and try to enjoy learning. Try to see learning as something good and enjoyable, and try to identify what you are good at. This must not be math or science. This can be sports or whatever, but identify what you are good at and please practice it and try to get better.
Excellent. Thank you so much for that, Professor Dr. Schmid. With this, I have a few other questions which we've received. The first one being, talking more about the seminar, if there's a certificate for it. Well, this was an informative session being done by Haba family of companies. So no certificate per se, but we are very happy to share information about it on our websites. We have everything. We'll share this after the seminar is over. We'll also share the recording because I've received some questions that they're not able to see. They were not able to see some parts of it. So all of that will be, as I mentioned before, Haba is present in India. So we will be talking about how can these products be made available. It will be through Haba India. So we have all that organized and planned. Here are the contact information from our side. Please reach out to us in case of questions. But before I conclude, I would like to again, give a vote of thanks to our panelists. Professor Dr. Schmid, one more time, I have to thank you for the wonderful session, because you've taken the time out of your busy schedule to help us give this insight into computational thinking and to sharing with us why it is so important. Mr. Fuchs, thank you for your time. Thank you for being here with us and helping us understand the products from Haba. How are they important? How do they lay a foundation for coding thereafter? Why is computational development skills important? I would also like to thank ScooNews, Ravi Satlani, for being a partner in this, for organizing this. And of course, the lovely audiences that we have joining in from, I mean, I see so many countries there. It really, it's so exciting to see that. So many people interested in coding in early years. So thank you, dear audiences, joining us live from different locations. It was a pleasure being here today, being able to talk about computational thinking, being able to introduce Haba again, talk about what we are working on, talk about the research we are working on, and let's keep coding. Let's continue to walk on the road of code. And most importantly, let's all keep safe. So on that note, thank you very much. It was a wonderful session.
Dann ja wart.